Hello everybody and welcome to today's lesson on quadratic systems. Yes, we are still talking about quadratic equations, and today we are going to take a look at when quadratic equations are part of a quadratic system. So today our learning objective is we will solve nonlinear systems of equations including linear quadratic and quadratic systems, and we will solve them algebraically and graphically. So what is a quadratic system? A quadratic system is a system of equations where one or more of the variables is squared. A system of equations where one or more, in our case it will maximum be 2, of the variables is squared. Now you remember systems of equations from Algebra 1. In there we dealt with the linear systems of equations. In other words, both equations were linear. Now one of them, or maybe even both, can be a quadratic equation. And if that is the case, then we have 5 different possibilities as to how many solutions we can find. In our first picture here on the left, we see that we have no solution. What does that mean? We see two parabolas. These two parabolas, both representing a quadratic equation, they don't intersect. They don't cross each other at any point. So there is no solution to this system of equations. Let's highlight that. No solution. In the next picture, we see a parabola, and that parabola touches at the very bottom, not right at the vertex, but very close to the vertex, touches a linear equation. And this is a system. It's a linear quadratic system, so it's part of the quadratic systems. This one has one solution. Going over further to the right, now we see a system with two solutions. That parabola can also be crossed by the linear equation twice, by the line twice. Then we're going to have two solutions. In our next case, we actually see a parabola and a circle. And the parabola touches the circle at the bottom at its vertex, but then it also crosses the circle 2 more times, and that way we end up with 3 solutions. And last but not least, we have the case where a parabola and a circle cross each other in 4 different places, leading to us having 4 solutions. So these are the 5 different possibilities shown graphically with how many solutions we could end up. And now let's look at how we find those solutions, particularly algebraically. And you remember from Algebra 1 that systems of equations can be solved by substitution. That's one of the methods that you can use. Let's look at the system here. We have the 2 equations to the left. We also have the graph here on the right showing what this looks like. Our top equation with the x squared is obviously our quadratic equation, represented by the parabola in the picture on the right. And the bottom equation is the linear equation, represented by the line that crosses the parabola in 2 places, here and here. So how do we solve this by substitution? We can see both equations are actually solved for y, so we can use this right part of the top equation and plug it into the bottom equation for y. That way we eliminate the variable y. That's why we call it substitution. and we end up with x squared minus x minus 6 is equal to negative 2 plus 2x. Now this is the equation we're going to solve now. We solve this by moving everything to the left, so we have the equation set equal to 0. In other words, we are adding 2 on both sides, and we are subtracting 2x on both sides, and then we have x squared minus 3x minus 4 is equal to 0. This looks like a quadratic equation as we have seen them and as we have solved them using different methods. Let's see if factoring works. And indeed, if we look at our target sum of negative 3 and our target product of negative 4, we realize that the two numbers are negative 4 and positive 1. And so we can write our equation in factored form, x minus 4 times x plus 1. And this leads us to our two solutions. Remember, we take the numbers from each factor, change their sign. So our first solution is x is equal to 4, and our second solution is x is equal to negative 1. That's worked very well for us. Now the fun really starts, because now we are going to use the x values and plug them back into one of our original equations to find the corresponding y value, which is part of our solution. So if we use x is equal to 4 and plug it into either of those two equations, both of them work. Both of them have to work, otherwise it wouldn't be a solution to the system. So which one are we going to take? The one that gives us less work, right? I'm going to choose the bottom one. And so y has to be equal to negative 2 plus 2 times 4. In other words, negative 2 plus 8. So y is equal to 6. And here we have our first solution, our first point, which is at the coordinates 4 and 6. Now let's find our second solution. And I'm going to plug x is equal to negative 1 into the same equation as before. So we get y is equal to negative 2 plus 2 times negative 1. Y is equal to negative 2 minus 2. That means y is equal to negative 4. And our solution is at the coordinates negative 1 and negative 4. Now let's mark these points also on our graph. We had our first solution at positive 4 and 6. That's the point up here. That works very well. And our second solution is at negative 1, negative 4. That's this point. Seems to work out. Excellent. Well done, guys. And let's move on to the next example. Here we have a nice quadratic function, y is equal to x squared, represented by the blue parabola. And this is, if you remember, the parent quadratic function, right? And the other equation represents a circle. X squared plus the quantity of y minus 2 squared is equal to 4 is represented by the circle in our graph. So now let's look at these two equations critically, and we can see that again we can use substitution because y is equal to x squared, so we can use that information and plug in the y instead of the x squared into the bottom equation, and then we end up with an equation again with only one variable. Y plus the quantity of y minus 2 squared is equal to 4. Now before we can proceed, or rather as part of the process, we are going to now expand that squared term in parentheses to make things easier. This part. So we get y plus y minus 2 times y minus 2 is equal to 4. And we need to go ahead and multiply that part out. Y plus y squared minus 2y minus 2y plus 4 is equal to 4. In the next step, I'm going to combine all like terms and subtract 4 from both sides. And I'm going to get y squared minus 3y is equal to 0. That looks much easier to handle, right? Let's go ahead and factor out the greatest common factor. Both terms here on the left have a y. And what's left after that is y minus 3. Everything equal to 0. And that gives us two solutions. Y can be 0. And y can also be positive 3. Very good. And again, remember, we need to now go ahead and find our corresponding x values. So I'm plugging in 0 for y. Again, you're free to choose whichever equation you want. I think it's going to be much easier for us if we use the top equation. 0 is equal to x squared. Well, if 0 is equal to x squared, then 0 is equal to x. And that gives us the solution at the coordinate 0, 0, which is our origin. This point right here. And the other solution will be at 3 is equal to x squared. Now we're going to have to take the square root of both sides. And we end up with positive and negative 3 is equal to x. Note that we have two solutions here. And the solutions for x are positive the square root of 3 and the negative square root of 3. So we will combine that with our y coordinates to give us actually 2 points. Positive square root of 3 and 3. And negative square root of 3 and 3. Those are the other two solutions. And indeed, as we see here, I'm marking red on red. Okay, whatever. You know what I mean. These are the 2 points that are the 2 remaining solutions of this quadratic system. Okay, so far so good, you guys. Now go ahead and watch the second part of this tutorial.